Let's discuss question number 8. First term, second and third term is given, and also given x greater than 0. So the first thing is we want to show that there is a equation exists like this: x cube 4x square. So we know that we have to build an equation, and when the first, second and third term is given with our experience, we know that it's clearly the common ratio. So we have to write the common ratio and make common ratio in two different ways: t2 divided by t1, and then t3 term 3 divided by term 2. Since it's a sequence, we can geometric sequence make it equal. So t2 is 2x divided by 8 minus x equal x square over 2x. So we'll cross multiply this one. So this is 4x square equal x square times 8 minus x. So we want the equation of this one, x cube. I can see x cube we are making x square 8x square minus x cube. So I'll bring to this one all the terms here. This is become positive and this is become 4. Okay, plus 4x square minus 8x square equals 0. X cube minus 4x square equal 0. And then part B, we find the value of 20th term. So we want to find the 20th term. So for this, we should know um, the first term and the common ratio, and this is going to be 19th. The first term we'll find, so we have to solve this one. X cube 4x square equals 0. X square is common, so I factor out. So this is x minus 4. Then we have two answers: x equals 0 or x equals 4. But given that x greater than 0, hence answer is x equals 4. So when x equals 4, we can write 8 minus 4, 2 times 4. Uh, Actually, we don't need to know the other terms. 8 minus 4 is 4. So this is the first term. We'll write nicely: a equal 8 minus x. So 8 minus 4 equal 4. And actually we need the second term as well. T2 equal 2x, that is uh, 2 times 4, that is 8. So the ratio R equal T2 divided by T1, that is 8 divided by 4, that is 2. So then we have the first term A is 4, sorry, first term is 4 and the common ratio 2. So the 20th term is 20 is 4 times 2 to the power 19. So this is the calculator answer. 2 to the power 19 is this one, and final answer. Part C of this question is we want to make see what. So 4096 term, 4096 value is a term of this sequence. 4096 is a term of this sequence. If this is a value of the sequence, then there should be a term exist, term number. So this term number 1, 2, 3. Likewise, there should be a term number, valid term number. So let's say that is n, and let's write n term. N term we can write a n minus 1. So um, we know a terms is a is 4, and the r is 2, 2 to the power n minus 1. And also we know that Tn equal 4096. So from here we can convert 4 to the power n minus 1 uh, equal 4096. And we have to solve this one, and if n is uh, whole number, then yes, it is exist. You can simplify 2 to the power n minus 1 equal 4096 divided by 4. That 2 to the power n minus 1 equal 101024. So we know that with our practice, 2 to the power n minus 1024 equal 2 to the power 10. Hence we know that n minus 1 equal 10. So then n equal 10 plus 1, that is 11. So 11 is a whole number. Then yes, this 4096 is a value of this geometric sequence. Just to revise you this one, 2 to the power, um, if you see the, I discussed somewhere already, if you see a to the power m and a to the power n, okay, let's say alpha and beta, since the base is same, then to equal this term, then this power has to be equal. So this is the theory. So when I get 2 to the power n minus 1, so then I assume if I can write this 1024 in base 2, then my job is done. So I know that I can write 1024 as 2 to the power 10. Then by this theory, I can write n minus 1 equal 10. Or the other way around is you have to work with the um, 2 to the power n minus 1 equal 1024. So apply log 2 to the power n minus 1 equal log base 10. Usually we don't write that. So then n minus 1 equal log 10 to the power 24. Sorry, n minus 1 times log 10 to the power 2. Then n minus 1 equal log 10 to the power, sorry, 10 to the power 1024 divided by log 10 to the power 2. So this value you will get as when you simplify 10. So n equal 10 plus 1, that is 11. Question number 9. Geometric sequence has the first term 200. So first term 200, second term we don't know. Likewise the first term, sixth term is given 40. So this is the first term T1, and this is T6. So T1 means first term is 200. Sixth term also given. T6 also, T6 is 40. Common ratio is P, R equal P. So T6 we can write, first term is A usually we write AR5. So in here, A value we know that 200 and R value we know that P and the power is 5. So from here T6 is 40, again T6 200 P5. The conclusion is 200 P5 is 40. Then P5 is 40 over 200, that is 1 over 5. P5 equal 1 over 5. The first question show that P satisfy the equation. This equation 5 log P plus log 5 equals 0. Now there is no log here and there is no power here as well. So we know that if there is no log here, so we have to introduce a log. And as a result, we know that we can bring this power down. So if I introduce log here, so 5 come down, 5 log P is there. Then this one. Mm, yeah, we'll see how we can do. So this is I can write P5 and P to the power, sorry, 5 to the power minus 1. Because what I realized was the minus 1 come here, then minus 1 bring into other side become positive. That's why I bring this 1 over 5 as a power minus 1. So we'll put log both side. Log P5 equal log 5 to the power minus 1. So then 5 come here. 5 log P equal minus 1 log 5. Basically minus 1 times this one mean minus log 5. So we'll bring to this side 5 log P plus log 5 equal 0. The second approach is for this log P5 equal log 1 over 5. That is, you can write this is as a division log 1 minus log 5. This is become 5 log 5 P and log 1 is 0. 0 minus log 5, 5 log P. So bring to this one 5 log P plus log 5 equal 0. Then the next part, hence or otherwise find the P. Otherwise we can simply find, so P5 equal 1 over 5. So take the fifth root, 1 over 5. So 1 over 5, fifth root. So this is P. So basically 1 over 5 over 1 over 5. Or P equal 1 over 5 to 1 over 5, fifth root. So you can take from the calculator. You can find hence. So 5 log P equal minus log 5. Then log P equal minus uh, log 5 divided by 5. And then P equal 10 to the power minus log 5 over 5. I take the log inverse, that since power is 10, so it is the base 10. But if you work with a different power, assume this is 5 ln plus ln 5, then this is going to be p to the power e to the power minus ln 5 over 5, because ln mean the base is e. If we work with the different power, different base. If this is let's say 7, then this answer has to be e to the power 7 to the power minus log 7 to the power 5 over 5. So all give the same answers. So you may get around 0.725. Question number 10. A geometric and the term first term 4, that is t1, and the fourth term t408. So when we have these details, we should know that definitely we have to find a and r. Actually, a is the first term is we know a equal 4, and fourth term is given. So T4 equal 108. T4 also you can write in terms of the first term and the common ratio, that is 3. So from here the conclusion is 4r cube equal 108. So r cube is 108 divided by 4, that is r cube is 228.7. So r cube, so this is 3 to the power 3. So r equal 3. This is another theory that if we have uh, a alpha equal b alpha, then since this is alpha, the only way we can this term and this term equal if and only if a equal b. So this is the thing that I discussed. Last time I discussed a alpha and a beta. Since base is similar, alpha equal beta. Now this is the other way around. Yeah, r equal 3. Now the question is, find the smallest value of k, which k that in this sequence exceed 500,000. So in this sequence, 108 not exceed 500,000, less than. There may be a value that exceed 500,000, and just before that value it will not exceed 500,000. Assume this is alpha, alpha not exceed 500,000, but beta, so beta exceed 500,000. So in this sum they have referred as beta as k. After that, any k is more than 500,000, because I can see this is a um, ascending sequence or divergent sequence. Sequence is diverging. Now we need to find that k, the smallest k. Smallest k is here. So assume that term is tk. So then what is the, so tk we can write first term 4 times common ratio, that is 3 times r minus 1, sorry, k minus 1. Actually we are talking about the kth term, so this is the k. We can leave this value as beta, kth term. So kth term we can write like this, and beta can be any value more than this one. So we'll apply, so tk equal beta, so we'll apply here for 3 to the power k minus 1 greater than 500,000. Now this is 3 to the power k minus 1 divided by 4, divide by 2, 250, then another 2, 125, 3 zeros. Now we need log OLN base to take. So log um, 3 to the power k minus 1 base 10, log 10 to the power 125, 0. And then this will become k minus 1 times log 10 to the power 3 over log 10 to the power 125, 0. So k minus 1 greater than log 10 to the power 125 triple 0 divided by log 10 to the power 3. So this value, when you calculate, you may get approximately k minus 1 around 10.68. So k is greater than 11.68 minus 1 to other side. So it can't be 11 because 11 is less than. So we have to approximate. So k equal 12. It means 12th term is greater than 500,000, but the 11th term is less than 500,000. There is no term, exact term for 500,000. Hence 500,000 is not in the sequence.